Hello, everyone. So, welcome to the session of AI in Action, where we will be telling you the real world applications and case studies of the artificial intelligence that we use in our project. So, the key modules that we'll be showcasing you today are the real world applications of AI across different industries such as healthcare, finance, and retail. Present you the case studies demonstrating successful AI projects and their impact, discussing the challenges and ethical considerations in implementing AI solutions, and to inspire you with innovative AI applications and future trends. So we'll be going across a few of the projects that we have done and are currently in progress. So this will give a better understanding for you to know the insights as to how AI works in our industry. Okay. So this is the first project in which we have got a business problem, which is at hand is to conduct comprehensive risk assessments to identify potential hazards in the scrap-based liquid steel production process. Okay. So this is the business problem that we have. And then objective is to maximize blast furnace safety. Yeah. So business problem, please understand that we have to conduct a comprehensive risk assessment to identify the potential hazards that can happen in the scrap-based liquid steel production process. And objective being the maximize blast furnace safety. But yes, at every objective, there are constraints. And here the constraint is to minimize the cost. So this is the model architecture that we have gone with. So the primary being the data that we have collected. So the client have given us a raw data, and then we have a secondary data that are available from images or from Google. So RoboFlow is the technique that we are going forward with. And yes, so in that we have data pre-processing and image flowing in that. Okay. Yeah. So then in the image, frame cropping happens of the data. Annotation is being used using RoboFlow. Data augmentation, that is the resizing, flipping, rotating, or scaling of the data is happens here. Okay. Then after that, we go to YOLO V8. We'll understand in very deep as to what the model building is, how it is done, why is it done, and what are the different techniques for that. Yes. Then, in terms of model evaluation, we do the model evaluation using precision, recall, and map. Okay. After that, there's a Streamlit we deploy using Streamlit, and then monitoring and maintenance is what needs to be catered to. Okay. And then finally, when it's done, we showcase it to our client, and then based on it, we predict or we have some future predictions or conclusions with us that we present it to the client with the proper reasoning, and then basis our conclusion, they implement in their business. Okay. So see from the bottom left, it goes from business and data understanding, which is why you understand the business thoroughly, right? After that, you move towards the data acquisition. So business understanding, data understanding is the most important step. Because when we get a project, so the domain may be of some other domain. We have not gone through that domain in our past. So to understand the business is very critical. And when we understand the business thoroughly, is when we try to understand the data. Okay. So then when we get the data, we get it, there are primary sources, there are secondary sources. So primary in this case has been given to us by the client. Secondary, we take it from Google, and so on and so forth. The model architecture is in front of you. After that, we deploy the model. Yes. So there are various upload options, choose whether to upload a video or an image. And then there are hazardous material detection. So, you can upload a video or image to detect hazardous materials using YOLO V8. Okay. So there are various options as what you would like to do. So on, you can do that. Okay. Moving forward, here's the output Okay, this might look confusing at once, but we will go in very detail and you will understand here what YOLO V8 means and what are the different parameters for its selection, and then what are the evaluation results, then what are the metrics that we have used for each class, what's the speed, and so on. Okay, to start out with, this image shows the evaluation result of a YOLO V8, which is you look only once version 8. All right. And then this YOLO V8 object detection model trained to identify various classes of objects. So here's a breakdown of the information displayed. Model and hardware information, that is YOLO V8.2.79, which you can see. So this is the version of the YOLO object detection model used. Then Python 3.10.12 is the Python version. And then there is CUDA0, that is Tesla T4 or 15102 MIB. So the model is running on a GPU, NVIDIA Tesla T4, utilizing CUDA for acceleration. Okay. So after model and hardware information comes the model summary. It has got 168 layers and 11,129,067 parameters. Okay. So it's 11,129,067 parameters. The model consists of 168 neural network layers with over 11 million trainable parameters. 28.5 GFLOPS. It represents the computational complexity of the model in terms of gigaflops. Then comes the evaluation result. So, while this line indicates the validation dataset path being used, that is 82 images. And then we have classes are evaluated. Number one goes with the class, that is different object classes that the model is detecting. Example, canisters, capacitors, cylinder. Then images, number of images containing instances of each class. And then instances, total number of objects of each class detected. All right. After this comes the metrics for each class. There's a box P, which is a precision of bounding box prediction for each class. You can see that. It's the fourth column. Then there's a R just after that, which is the recall of predictions representing the ability to find all relevant objects of each class. Then there's map 50, which is the mean average precision at 50% intersection over union threshold, indicating how well the model detects each class with a 50% overlap. Then there's a map 50-95, which says the average precision across multiple IOU threshold from 50 to 95%, showing overall detection accuracy. For example, canister. Let's look at that. So canisters are the precision of 0.885, a recall of 0.917, map 50 of 0.949, and map 50 to 95 of 0.899. After this comes the shock absorbers. So precision of 0.937, recall of 0.832, map 50 of 0.893, and map 50 to 95 of 0.669. Okay, so these are the few examples. Now let's proceed to the speed. Okay, so for the speed, we have a pre-process 5.5 milliseconds, which is the time taken to pre-process each image. Then there's an inference of 12.1 milliseconds, which is the time taken by the model to make predictions. Then loss is 0.3 milliseconds, which is the time taken to calculate the loss during training. And then there is a post-process of 12.4 milliseconds. It's the time taken to process the model's output into final predictions. So now that you have got the idea of what it is, I hope this is very much clear as to what the business problem was, what the objective was, what the constraint was, and how from there we understood the business, the data, the model that we have evaluated, deployed, its monitoring, maintenance, and finally presenting the client of its output. So overall, in summary, this output provides a detailed evaluation of the YOLO V8 model's performance, showing it performs well across most classes with high precision and recall while running efficiently on a GPU. So this is what this project was all about. I hope you have gained a deeper insight into this. So let's proceed to our next project. For that, the business problem. So the business problem at hand is the on-demand generation of content for a wide variety of courses. So now this comes into the educational department or educational vertical, in which for a wide variety of courses offered by the university. Due to the high demand for such questions, creating them manually will require too much time and manual effort. Please look at this problem once again. So the business problem says that there's an on-demand generation of content for a wide variety of courses, right? So as the time is like as in the future, so there's a demand for content, and there's a demand for content in the educational institutions as well, because of which there's a wide variety of courses that being offered by the university. But due to the high demand for such questions, creating them manually, imagine creating them manually, all the courses or all the content that required. So manually creating data for that is a very time-consuming process. It's a very tedious process. So it will require too much of time and manual effort. So this is the problem. Now, objective is to maximize content generation quality with the minimum possible time, and constraint being to minimize the plagiarism of content. Okay. So when we have objective as to maximize the content generation quality with the minimum possible time, at the same time, we have a constraint which is used to minimize the plagiarism of content. Yeah. So content should not be repeated. It should be unique. Okay. So we have to cater to that as well. So here's the model architecture. Okay. So please have a look. And meanwhile, I'll start from the very basics so that you have a deeper understanding. So as and when I have said, whenever we get a project of any domain, the first thing is keep it a benchmark. The first thing that we do is to understand the business. Without understanding the business, we should not proceed to the data. Yeah, so it's very habitual for the freshers or for the newly experienced people. As soon as they get a project, they just want to jump onto the data and do the pre-processing or the analyzing part or the model building and all. But before all that, the most important thing that needs to be focused upon is the business understanding. We should have a deeper understanding of how that business works, because without that, we can't function. Whatever the data that we have, we won't be able to understand the importance of that data, how that data is interlinked, which of the column or the rows are connected to each other, or can be connected for a better output. So all these understandings we gather from understanding the business thoroughly. And this is the primary and the most important step before we step into any project. Okay, any project starts from business understanding. So after that, so once we have understood the business now, how business deals with it, how the customers are, so what sort of transaction happens between the business and the customers. So now we'll know what the dealing is. Yeah, how the business operates, what are the different parameters that we should keep in mind before moving ahead with its analysis. After business understanding comes the data acquisition. So once we have understood the business, now we will focus on the data. Yes. So what sort of data we have got? Is there any scope of extracting more data from the client? Or if the client is not giving the data, or if let's say they have limited data, right? So we have the option of looking for the secondary data, yes, from online or anywhere. Whatever research we have done in business understanding, that will also help to gather data in a secondary manner. Okay. So whatever data that we acquire, there's a primary data that we get from client, and then there's secondary data. Okay. So there are various websites from which you can get the research articles and then the corresponding data as well. Yes, you heard that right. Data is also readily available along with the research articles. So whatever research that it has been uploaded to on Google Scholar, so there are many articles in which the data set is also provided for the users to have a look as to what the data was, after which the following research was done. So that gives an even better understanding of how it functions. So when we acquire data now through the client or through the secondary resources, then after that comes the data pre-processing. So now let's see. We started from business understanding. We understood the business. Then we took the data, yes, be it from the client or from online channels. So now we have the understanding of the business, we have the data, we have the understanding of data as well. Now comes data pre-processing, in which there are various functions or various, calculations that can be used to pre-process the data. Yes, all that whatever we have learned in our EDA, that's a part of it. Along with that, what can be done is tokenization, text normalization, and vectorization. Yes. So after doing that, for model development, so, now we have understanding of the business, we have the data, and now we have pre-processed the data as well. Yes, whatever refining or cleaning the data was required, we have done all that. And along with that, we have done tokenization, text normalization, and vectorization. After that, when we come to model development, so, we will have different models which we can try, starting from Vicuna or GPT Neo, Gemini Pro, Hugging Face GPT-3, or Llama 2 suite. We can try for different versions. So once we check all these models, so we can understand which model works better. Yes. So you can see later on in the best model section, we have taken Gemini Pro because that suits the best here. Okay. But before that, when we have like few models which can be developed, we undergo the evaluation phase. So, we evaluate it. All the models, whatever we think that can work, we evaluate them. We just don't pick and say, hey, I like this model and let's build on this. No, it's not like that. We are into the data industry. So anything and everything works on the data. So whatever data that we have to implement on that. And whatever the data that we already have, basis that only we can select the model and evaluate it, and then out of that select the best model, not before that. Okay. So this is how we proceed. So here in evaluation phase, we look for its performance, we look for its robustness, its explainability, and whether it is plagiarism free. So see what are the 4 steps that we have undergone for all the models that we have taken. We check for each of the models performance. Okay. So once the performance has been checked, we look for its robustness. After this, there's an explainability quotient, whether what we are trying to know if that can be explained using the model or not. And then whatever model that we use or whatever we agree upon to take it forward, whether it is plagiarism free or not. Because if you remember, plagiarism free is the only constraint that we have. Data generation is itself a task, but then making it unique is altogether a different thing. There are numerous data available, numerous content available on website. For any of the course, we can have all the generated content, but it has to be unique. So to make it unique, we evaluate all the models basis the performance, robustness, explainability, and whether it's plagiarism free or not. Okay. So we check for the hyperparameter tuning. Okay. Since it's a pre-trained model. So after this evaluation phase, we have narrowed down upon Gemini Pro, which is the best model as per the objective and the constraint. And after going through this evaluation stage, we have narrowed it down to Gemini Pro. Okay. So once we have taken that model, then we go for its visualization. Okay. So once we have gone into that visualization, after that, when the model has been selected, it goes into the deployment stage, it goes into the monitoring and maintenance stage, and then we present it to the client. All right. So when the model has been selected, data visualization is what happens here. Okay. Then after the visualization is being done, we present it to the client for explaining them as to what conclusion have we arrived upon. Because basis our conclusion, they will implement whatever decisions that they have to in their business. Yes. So we have solved their business in a way. Okay. So this is how model architecture looks. Now, this is how we deploy the model. So you can upload the PDF files or click on the submit and process button, and that will be submitted. And you can see the different question types that can be either MCQ, a true false, a short answer, or a detailed answer. Okay. So Gemini, this is a smart PDF Q&A generator and interactive chat box in which the answers will be of these types. Okay. So whatever we select here, accordingly, those content will be generated. Okay. So after that, this will be the output. So we have asked a question, what is self-attention mechanism? And see, basis that we have an answer. And trust me, this answer has come in a very short period of time. It has fulfilled all the objectives. And then it is plagiarism free. It has taken care of the constraint as well. Because whenever we go for the project, objective needs to be fulfilled, but constraints also need to be checked upon, whether constraints are being taken into consideration or not, because that is important, right? So unknowingly, there are times when we move towards the objective and there are the cost of that objective fulfilling goes on increasing. So we have at some point of time a constraint where we have to minimize the cost. We saw in the first project that we just saw. Okay. So basis that, we have always to be keep in mind to check with the constraints. Okay. So let's move forward with our third project. It's on autism. Okay. This is going undetected. So autism related behavior has been increasing by day by day. So this is a problem that we have. And then what is the objective? Objective is to maximize the early detection of autism. What is the constraint? It is to reduce the manual effort. Okay. Business problem, autism going undetected, autism related behavior increasing by the day. Objective is to maximize the early detection of autism, and constraint is to reduce the manual effort. So this is what our third project is all about. Then business success criteria. It is to increase the autism detection in kids in early stages by at least 7%. Okay. So this is a criteria in which we can evaluate whether the business is successful or not. So how it can be evaluated? Whether we can increase the autism detection in kids in early stages by at least 7%. Then the economic success criteria, it is to minimize the government spend on autistic kids. Yes. So very fruitful, objective, constraint, the business success criteria and economic success criteria. See, when the business success criteria, which talks about the successful event of business, how and when it will be successful, we have seen that, whenever increasing in autism detection in kids will happen in early stages by at least 7%, then our business will be successful. And when we talk about economic success criteria, it is to minimize the government spend. Whatever the government has been spending on autistic kids, these need to be checked upon. It needs to be minimized. That is what the economic success criteria is. Okay. Then going forward, the model architecture. So now look at this model architecture. This is very important because once you understand this, you will understand the entire project. Yes. This is a gist or a brief summary of where our project starts and where it ends. So let's move. You can see the business understanding. As we have discussed, the first and foremost thing whenever we go into a project or whenever we start a project is the business understanding. This is the most important step. And once we understand the data, understand the business, then only we can understand the data and henceforth the entire project maybe. But how the business happens of that particular domain is what needs to be understood. So once business has been understood thoroughly, while doing the business understanding, there are different articles present on the website. Google Scholar, as we discussed earlier. So, these articles, once you go through, you can find that there are many different versions of the same problem that you are encountering with. Yes, the objective may be something different, a bit different maybe. Yeah, the constraint may be something else. The success criteria are maybe something else. But some or the other article will have this kind of business problem or something other. The tangent may be same. It may not look like exactly the same problem, but something different. In the same vertical also it can happen. Okay. So whenever we go through that research article, that itself opens our mind as to how we should go ahead with, how we should plan ourselves, what's the basic step that we should, make it happen. So all these are very basics of understanding the business. And as we mentioned that these businesses have got data. So these data makes you even more understanding clearly as to what this project entails. Okay, because whatever research has been done, if the data set is in front of you, so you'll understand it even more. Yes, because that data will speak volume, and then you have something to represent that data. So when you have that, the picture is very clear, or you can say the picture is crystal clear. Okay. So after business understanding, we will proceed to data understanding. As we saw, that once we understand the business, we have to understand the data. Data understanding is the second step, and after business understanding, the most crucial step. Because once you understand the data, why about the different columns that it has, about the different rows, different headers, what impact does one have on the other, that is very crucial. Basis that only it will happen, right? So after business understanding comes the data understanding. In this case, we have video data, right? So once we have the data and we understand that, comes the data pre-processing. Okay. So data pre-processing, as we have done umpteen number of times, refers to the pre-processing or refining of the data that we have maybe from the client or from the secondary resources. Once we have the data now, we store that data into S3 bucket. Okay. That data is being stored in the S3 bucket. And then after that, the modeling techniques happen. Okay. So let me give you a very brief understanding, detailed understanding of this project architecture. I hope by now you are, clear of how this project architecture looks, right? So let's say after data pre-processing, it goes to the S3 bucket. Yeah, that is in the form of bucket only. And then it goes to that model building and tuning. Okay. Then we have different models in which model evaluation is being done as discussed, right? So model evaluation, whether which model suits the best, whether this is good or this is bad, and the different metrics that we saw, right? Of detecting the models and evaluating it basis some performances of them. Yes. After this is done, we do the model compression. So whatever model that we finalize upon, in coding there is a word optimization. Optimization refers to the whenever we have codes in larger number of lengths, so we just try to reduce the lines. Similarly, this model compression is a technique as to reduce the model in a way that it is used in an optimized manner. Okay. And once this is done, we deploy the model. We take monitoring and maintenance to its core. And then once we have the output, we present it to the client. Okay. This is how our model architecture looks. Though now we will understand it even more. Okay. The different nuances of it. So the project architecture from this image that illustrates for a system involving video data analysis. Okay. See, after business understanding, there's the video data. So for data understanding, we have the video data that needs to be analyzed, likely using deep learning models, CNN and LSTM, for some form of recognition or detection task. Okay. Now, business understanding, we have gone through this thoroughly, that the understanding requires us to know about the business and its objective. This includes identifying the problem that needs to be solved and determining the goals and success criteria for the system. Okay. And then in the video data collection. The video data is collected and stored, which will serve as the primary input for the system. Okay. So video data that is collected and stored, which will serve as the primary input for the system. Then comes the data pre-processing. As we all know that this step involves preparing the raw video data for model training. Then pre-processing may include steps like extracting frames, resizing, normalization, or other techniques to make the data suitable for analysis. So that's the primary and the most important function of data pre-processing, right? That, we have to do apply different functions, different techniques to make the data suitable for analysis. And in this case, what all steps can we do? It's like extracting frames, resizing, normalization, or other techniques. There can be data missing, so imputation can happen. Okay, maybe two columns, they have the almost moderately, they have, correlation coefficient and very strongly related. So one of the column can be deleted. So all those things can happen. If we have, duplicate rows, one of that row can be deleted. So, along with, as we say that we need to optimize the code, we need to optimize the data as well. We need to check how many of the columns are required for analyzing the data, and the remaining can be deleted or just hidden. We don't delete anything, or just hidden from whatever we are doing. Okay, so this makes the data optimized. Then let's talk about its storage. We have the data and raw data, we have the video data, and then when we use for its storage, processed data is stored in a S3 bucket, a type of cloud storage, which is a common practice in machine learning pipeline for managing large data sets. Okay. Then comes the CNN and LSTM model building. CNN, or convolutional neural network, used for feature extraction from the video frame. CNNs are effective in handling spatial data, making them suitable for analyzing images in the video. Okay. CNN, or the convolutional neural network, it is used for feature extraction from the video frame. Okay. And then CNNs are effective in handling spatial data, making them suitable for analyzing images in the video. So whatever images we have in the video, CNNs are effective in analyzing that. So it is a very important tool that we have to use here. Okay. Then comes LSTM, or the long short-term memory network. Now, this is used to handle sequential information from the video, capturing temporal dependencies between frames. Combining CNNs and LSTMs enables the model to analyze both spatial and temporal aspects of video data. Clear with LSTM? I'll explain it again. LSTM, or the long short-term memory network. This is used to handle sequential information from the video, capturing temporal dependencies between frames. Combining CNNs and LSTMs enables the model to analyze both spatial and temporal aspects of video data. Clear? Then we proceed on to model evaluation. See, after going through the CNN and LSTM model building, then we proceed to model evaluation. We have all the models, and now we will evaluate them. on the different metrics. Okay. So model evaluation. The trained model is evaluated to ensure it meets the performance criteria. Evaluation metrics like accuracy, precision, recall, or F1 score may be used to assess how well the model performs on test data. So were you able to focus on the different metrics that's being used in evaluation? The different metrics are accuracy, precision, recall, or F1 score that may be used to assess how well the model performs on test data. Okay. So this is the model evaluation. Now comes the model compression. So model compression, this step involves compressing the model to reduce its size, making it more efficient and suitable for deployment. Okay. Model compression, this step involves compressing the model. We discussed it, right? Model compression involves compressing the model to reduce its size, making it more efficient and suitable for deployment. Okay. Techniques like pruning, quantization, or knowledge distillation may be used to reduce model complexity without sacrificing much accuracy. Okay. So this is how model compression works. We have to reduce it to make it work even more effective manner. Yes, same goes for the code. So the code also we try to optimize it to lessen the number of lines so that it can be optimized and used in a efficient manner. Now comes the model deployment. So after model compression comes the model deployment. The compressed model is deployed into a production environment where it can start processing new data in real time or in batch mode, depending on the system's requirement. So whatever, model that we have chosen from after going through the evaluation process and compressing it, we finally deploy that model. And the compressed model is deployed into a production environment where it can start processing new data in real time or in batch mode, depending on the system's requirement. Okay. So after model evaluation, model compression, model deployment comes the monitoring and maintenance part. Okay. So in which we monitor the model that we have deployed and at periodic intervals, we maintain that. Okay. So after deployment, the model is monitored to ensure it continues performing well over time. Maintenance includes checking for data drift, retaining if necessary, and updating the model based on new data. Okay, this is what comes under monitoring and maintenance. That after deployment, the model is monitored to ensure it continues performing well over time. So after deployment, it's not like we just leave the model and perform it as per its own wish. We continuously monitor it to ensure whether it continues performing well over time. After we deploy, we will, hope to make it maximum, right? So till the time, we shouldn't touch that model. It should be maximum as per us. Okay. So that is what is ensured using continuous monitoring and maintenance. Okay. Even if slight maintenance is required to check something, we will do that. But we want that code to run thoroughly. and continuously for a longer period of time. So, maintenance monitoring, after deployment, the model is monitored to ensure it continues performing well over time. Maintenance include checking for data drift. Yes, data should not be drifted away. Then, after this, retraining if necessary. Okay, so if anyone needs retraining, if necessary, then we should do that. Yes, model needs to be trained before being deployed. And if after deployment, in the monitoring and maintenance phase, if we come across something which needs to be trained, yeah, so the model is trained accordingly. Yeah, and retraining can also happen. And this retraining will update the model based on new data. So, let's say every year or every month, the client gives us new data. So it can happen that in some particular month, there's something drastic happened. Maybe the sales dipped or maybe the sales peaked. Yes, anything can happen. So during these times, model needs to be updated because model calculates basis each and everything, and it just gives a simpler output if there are no causes to make it reach at the peak or at the bottommost. So if there are circumstances which are making the data look like that, then the model needs to be updated accordingly because that fluctuation has to be measured. Okay, so this architecture showcases a comprehensive end-to-end pipeline for video data analysis using deep learning models, emphasizing on storage, pre-processing, model building, deployment, and ongoing monitoring. Okay, so even after this, if one looks for the model, whether it's working perfectly or not, there can be issues, right? Retraining can, like if required, retraining has to happen for the model. Okay, so basis that it will give the updated conclusion. So this is very important. The model also has to be updated with the updated data. It shouldn't be the case that data is of the past and model is acting as per the data, and then we have some new data with us which is in stark contrast with what we had earlier. If that's the case, our model will have to work differently in a very diligent manner. And for that to happen, we will have to retrain the model. All right. So this is the third project. Now let's come to the fourth project. Okay. This is even more interesting. So it has got business understanding. Okay. This is the important thing that we go through. And here we have a gist of the business to, for us to even understand it better. So XYZ is a leading Indian hospital chain specializing in advanced fertility treatment, including in vitro fertilization. The hospital offers state-of-the-art embryo classification services using cutting-edge technology to assess embryo quality and improve success rate for assisted reproductive procedures. Okay, so we have been mentioned about an Indian hospital chain specializing in advanced fertility treatment, including IVF, which has been, in our daily lingo from some time now. So the hospital offers state-of-the-art embryo classification services using cutting-edge technology to assess embryo quality and improve success rate for assisted reproductive procedures. Okay, now let's understand what the problem is. So business problem is Because of increasing stress levels and changing external factors, parents are unable to bear a child using natural phenomena. Okay. Hence, in vitro fertilization procedures are on the rise, which is part of assisted reproductive technology or the ART. However, the success rate of these procedures is also low due to high inter-observer variability in grading the quality of embryos by embryologists, and in some cases, patients come to know about the result after 4 months. See the problem? The patients come to know about the result after 4 months. Okay? So high level solution is what implement AI-driven embryo assessment system to reduce grading variability and provide faster, more accurate IVF results. So the business objective being to maximize the success rate of ART procedures, business constraint being to minimize the treatment cost. Yes, treatment cost should not be at its peak level. It should be minimized. And then we have a business success criteria, which says to increase the success rate of ART procedures by at least 10%. And then we have ML success criteria, which says achieve an accuracy greater than 85%. And then there is an economic success criteria, which says achieve a cost saving of at least 25% by reducing the expenditure on working with embryos of lower grading. Okay. Moving forward, data collection. So, we have collected image data consisting of embryos in different stages of development. So the client data, we had 3,566 JPEG images. Okay. So then after that, we did the data preparation step in which we did data labeling or annotation. Data annotation was performed to identify the good and the bad embryos. And then data augmentation was done, in which it was performed to increase the amount of data, which in turn increases the accuracy of the AI model. Rotating, scaling, flipping, adjusting brightness, adjusting contrast were the different steps applied. Okay. After that, here's the architecture diagram. It's a high level design. It is for the training pipeline versus the inference pipeline. So as you can see, any project, we start off with business and data understanding. Okay. After that, we go to the data collection part. And once we have the data, we do its annotation. And then this data is being stored in Amazon EC2. Okay. After that, in the data pre-processing step, we do the data annotation, we do the normalization, and we do the image resizing. Okay. So these are the data pre-processing steps that we do. After that, once we have the final refined data, we again store it in Amazon EC2. And after that, we do the model building stage. Okay. We do the model building, and after that, we go to the evaluation stage. Okay. So in this model building stage, we do different steps as in the CNN models, ResNet, VGNet, MobileNet, etc. Okay. After that, we do the monitoring and maintenance. So this is a detailed level design in which we can see the different data sources. It can be primary, secondary, and all. Okay. Since there it's only primary. After that, we go to the data warehousing, EDA, data pre-processing, then comes the model selection, model training, model evaluation, model deployment. Okay. This is the detailed design. This is the strategy. Please go through this strategy for a minute. Okay, I hope you have gone through this, the strategy of model deployment, and I hope you have gained a better understanding as to how this is done, why this is done. Okay, so model deployment, as the name suggests, and we have seen in our past 3 projects, that it refers to the process of making a trained model available for use in a production environment. This involves taking the trained model and integrating it with an application of system so that it can be used to make predictions or generate output. Streamlit is a Python-based open source web application framework. Yeah, you can see the Streamlit, right? So this is an open source web application framework which is used for building interactive and data-driven applications. It enables developers to quickly build web applications using Python by providing a simple and intuitive API for building web interfaces. Okay, so this is the model deployment strategy. We have been, deploying models since our very first project, which we have showcased here. So the strategy is very important as to why that particular model is being used, how it is integrated, how it is trained as per the data, and the first and foremost, how is it selected basis the evaluation metrics. Okay, so then this is the model deployment. This is the MBO classification and image annotation which we learned. So, basis that we can upload all the files and get to its detailing. So today we saw 4 different projects in which AI has been used. Okay, and how it has been implemented, how from the business understanding we went to the data understanding, data extraction from the client or secondary resources, and then we went ahead with the model deployment, data pre-processing before that, then the model deployment, and then the monitoring and maintenance, and finally giving the client a final output with some conclusions. Okay, so these are the very important steps in a project when we do, and it is preferred to follow the process thoroughly, right? The logic of approaching a project is very important. So if you know where to start from, where to end, then entire hustle is over. Okay. Okay, friend. Thank you so much for your time. Happy learning.